logarithmic function or log function. F of x is equal to log with base a of x, where a greater than 0, a not equal to 1, and x greater than 0. Now we know from the previous presentation the inverse of an exponential function is a log function. So here's the graph of a log function. So where the y-axis is the asymptote and the domain here is from parenthesis 0, comma, positive infinity, and the range would be all real numbers. That's parenthesis negative infinity to infinity. And if we remember the graph of exponential function, the asymptote was the x-axis, so this is actually the opposite. So the curve is something like this. So it's actually the reflection of the exponential function, and that is the log function. The reflection of the log function is the exponential function. So with respect to the y is equal to x. So if you look at the equation here, if you remember taking the inverse of a function, you will switch the x and the y or interchange the x and the y. So our exponential function was y equals 2 power of x. So this is our exponential function here. And if you switch the x and the y or interchange the x and the y, you will have x equals to 2 power of y here. And then if you take the log on both sides, you will get log of x is equal to log of 2 power of y. And what's next would be applying the property of logs. You will have to bring down your y here. It's like you're solving your y. You're going to have y beside the log of 2 here. And then dividing log of 2 on both sides. This cancels out here. You'll get y here on the right side, and on the left side you will get log of 2 of x using the Chain-Bayes theorem. So that's exactly the log function here. If you're looking at the log function here, so that's exactly the one. Remember, f of x is your y. So again, the inverse of exponential function is the log function, and vice versa. So you can call the y is equal to x here as the reflection line or the line of symmetry. Okay, so we'll try an example here. So let's say you're asked to graph the log function f of x equals log with base 2 of x. So here what we're doing is using our xy table. So we assign value for x and solve for y. Okay, so let's assign a value of 1/4. So plugging in 1/4 to our equation here. Remember, our f of x is our y is equal to log with base 2 of x. So the answer would be -2. Okay, you can enter exactly the value 1/4 to your calculator, and then you will get -2. Or you can do this using the log property or theorem on inverse. You can actually solve this by hand. So you have here y is equal to log of 2. Our x is 1/4. It's right there. And 1/4 or 4 can be expressed into a base 2. So you will get log of 2. So you will have to express your base 2 here, similar to your base of your fraction. So that would be 2 power of 2 here. So that's 2 times 2 is 4. And then we have to bring the bottom to the top. It gives us a value of 2 raised to the power of -2. And from the theorem on inverses, if you have this same value, the power is just the answer. So our answer therefore is -2. Again, you can always check this by plugging in exactly in your calculator the expression log with base 2 of 1/4, and it gives you a -2. We will try a value of 1/2 for x, and we plug that in, we will get -1. Okay, and you do the same thing as we did a while ago. So you plug in 1/2 there, 2, you move that to the top, you will have 2 power of -1. So -1 is the answer. And then when you have x has a value of 1 here, for x with any base, it's always a 0 as the answer. You can always try that using your calculator. And then our next value would be a 2 for x. So when you plug in 2 for x, same as we did with the first solution here, this one, we do also like y equals log, our x is a 2. Now 2 doesn't have a power, so this is understood as power of 1. So the answer is just 1. So therefore, our answer here is just 1. Okay, and let's take probably a value of 4. When you plug in 4 there, so just break that up into a base of 2. So you will have 2 power of 2. So the answer would be 2. So just take the power. And then if you have a value for x8, then your y would be 3. Okay, and then this is the time you can graph. So I would say you can have similar to a parabola, minimum of 3 points. So if you want to have a very defined graph, then you can have more than 3 points. But minimum would be 3 points. Okay. Please include the x-intercept in this case, so you will have a good graph. And so here's the graph now. So you have your y here, your x, that would be up to actually 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. And for y, we have up to -2 here. For the positive values for y, we will have, this is -1 here. We have a 1, then 2, then 3. And then we will plot the points. So let's take the first ordered pair, 1/4 for x, and then -2 for y. So that's somewhere here. So that's our first point. Our next point would be positive 1/2, and you will have -1, so that should be somewhere here. So the next ordered pair is 1, 0. So this would be our x-intercept. Remember, this graph is the inverse of your exponential function. Remember, the exponential function has a y-intercept. So since this is the opposite, so you will get x-intercept, and you don't have a y-intercept since y-axis here is your asymptote. So it's just approaching to the y-axis, but it never touches the y-axis. So here's our third point. Next, ordered pair is 2, 1. So 2 for your x and 1 for your y. And then 4, 2. So we'll have 4 for x, 1, 2, 3, 4. So that should be 4 somewhere here. And the point should be 4, 2. So that should be somewhere here. Okay, and then the next or the last ordered pair or last point, that's 8, 3, 8, 3. So that should be here. And then connect all the points. So you will form a smooth curve here. Okay, so note that the curve will not touch the y-axis. It's approaching the y-axis, but not touching it. And that's the graph. Okay, and you can assign any value for your x. We just actually use exact y values that uh, the x values are given. So you can see that's multiples of 2. So because when you plug that in, you can use the calculation by hand, not a calculator. So easier for you to get the y values using the theorem on inverses and the property of logs. So let's analyze the graph. So the graph has an asymptote. So as you can see here, if I'm going to write that down, there is a vertical asymptote, and that is x is equal to 0. Horizontal asymptote, we don't have one. We have only one asymptote. That's the vertical asymptote. Slanted asymptote, none. And then if we're going to look at the graph, there's no broken part. So the graph is continuous. And if you're going to trace the graph from left to right, you will get increasing function. So you're moving upward, so it's increasing for the entire domain. So increasing. So the interval here would be from 0, not touching 0. So that should be a parenthesis 0, comma, infinity. Because you're looking at the domain for the increasing. Do we have decreasing? No, we don't have decreasing part. Do we have constant? No, there's no horizontal line, so there's no constant. And if you're asked about the domain here is the same as the increasing part, which is 0 going to infinity. And then range, you look at the y-axis, the graph occupies all the y values. So you will have all real numbers. So that should be negative infinity going to infinity. So that would be your analysis of graph. So note that if you have some issues or doubts here, and if you want to double check your answer, you can always use your graphing calculator. You just enter the equation and then you hit graph. You can actually see if this one is matching with your result from the graphing calculator. So in our previous presentation, we use Desmos graphing calculator. You can also use that to verify your answer, to double check your answer, and to analyze more on the domain, the range. Is it continuous? Is it increasing, decreasing, constant? And where's the asymptote? So you can always use that tool to verify your answers. So this is the log function. And we know that a function is actually has only one intersection point when you do the vertical line test. So that's why we call this as a function. So you can always have like a vertical line test like that, and you have only one intersection. That means this is really a function. And you can tell also we replace y with the notation f of x. Okay, so that's log function.